All right, everybody, we are on to the second standard, and this standard is graphing and identifying key characteristics of quadratic functions. So that's exactly what we're going to do today. We are going to be graphing quadratic functions. So go ahead and get yourself ready to go. I will show you how to do this on a calculator when we're together, and we're going to get some more practice out of it, but we are right now just going to be working and doing this by hand, so we're going to be making tables and stuff. So whenever you're ready, let's get started. All right, so to start with this, we're going to go through the vocabulary, and I'm going to start by putting the parent function, which is the most basic, boring, non-translated quadratic onto our graph here. So the vertex here is going to be at 0, 0. And the next points that I'm going to do is if I were to square the number 1 and if I were to square the number -1, and you get a positive 1 as the result. Then I'm going to take the 2's, and if I square 2, I get 4, and if I square -2, I get 4. And then I'm going to go to the 3's, and if I square 3, I get 9. And if I square -3, I get 9. So this is where our shape comes from. It is not a V, because as you can imagine, when I square 4, it's going to be way up here at 16. So this is actually forming a U shape. It is something we call a parabola. A parabola. And we may also say that this shape is parabolic. Okay, so we can use the word it's parabolic or it is a parabola, just so we have the vocabulary correct. Now, our vertex in this case is 0, 0. It is an ordered pair. It's the same as we would find if we were using the absolute value functions we worked with. Our axis of symmetry in this case is x equals 0. It is a vertical line, just like with the absolute value. The domain, there's not a single number you can't square. Positives, negatives, 0, it doesn't matter. So this domain is all real numbers, which you can write as -infinity to +infinity if you'd like. And the range. The range in this case, just like the absolute value, comes from the bottom and goes up, or if we flip it over, it's from -infinity up to the top. So we have 0 to +infinity, and we're including the vertex. In this particular case, my x-intercepts, there's only one of them. That x-intercept happens to be the vertex. So this is where you may have to find different methods of calculating this, but it is where it crosses the x-axis, so you're looking for that location. And the y-intercept, again, in this case happens to be the vertex, but it's a special case in which that is. So this is also where it crosses the y-axis. So we'll talk about those as we move forward. So let's try our first example. And we're going to be given these quadratics in different forms. This one is in vertex form. And if you were trying to solve this, you probably would solve this using inverse operations. But we're not solving, we're graphing. So we're going to identify our vertex just like we did with the absolute value, and that is 3, -9. Our axis of symmetry is exactly the same way. It's going to go right down the middle of our graph, which means it goes through the vertex, so it's x equals 3. The domain is all real numbers. We're going to wait on the range and the minimum and maximum until we actually go ahead and put this on the graph. So let's do that. We're making a table. The vertex goes in the middle, just like when we made it for our absolute value graphs. And I'm going to choose numbers on either side, so like 2 and 1, and then 4 and 5. When we choose the numbers here, you're just kind of keeping them in order, but remember, because it's symmetric, just like the absolute value, if I find the value for 4, I also find it for 2. And if I find the value for 1, I also find it for 5. So I'm going to substitute the 4 in because it's going to keep the value inside of the parentheses positive. If I put the 2 in there, it'll just make it negative. And I'm just trying to make it simple for myself. So this is going to be following the order of operations. 4 minus 3 is 1, squared makes 1, times 2 minus 9 makes a -7. And I would have the same thing for the 2. Substitute in the 5. 5 minus 3 is 2. When you square it makes 4. 4 times 2 is 8, minus 9 is -1. So these are some points that I can go ahead and graph. So let's go ahead and do that. You can pause if you need to, or just follow along with me. All right, so there is my graph. And I can see from this point, my vertex is in the right location. My axis of symmetry goes right down the middle. My domain is all real numbers. My range goes from the bottom, which makes this a minimum. It is a minimum that my range is from -9 to positive infinity. Now, we did not look for our y-intercept or our x-intercept. To find the y-intercept, it's very simple because I'm just going to substitute in a 0. So I can go up to my equation, substitute in a 0, and I can find the y-intercept. So that would give me -3 squared is 9. 9 times 2 is 18. 18 minus 9 is positive 9. So this would cross at 0, 9. The next point would be right up there. This is where it would cross. My x-intercepts, I'm going to have to set this equal to 0. I'm not replacing it with a 0. I'm setting it equal to 0. So I'm recommending you go ahead and give it a try. And I want you to set it equal to 0, and this will help you find the x-intercepts. When you find them, they're not going to be pretty numbers because we are going to be taking the square root of a fraction. So, and that means they're just approximations, and that's okay. All right, the next one is standard form, and I'm starting you off with what standard form is, and we know this because it's what we use often when we factor, and it's also what we use for the quadratic formula. So our vertex actually starts by us finding the axis of symmetry. So that means that we have to find the x value of the vertex first. And we do that by taking the opposite of b over 2 times a. Well, that should look familiar to you because it is part of the quadratic formula. It is the very first thing you say in the quadratic formula and the very last thing you say in the quadratic formula. And this gives you the x value of the vertex, which happens to also be the axis of symmetry. Once you find the x value of the vertex, how do you find the y? Well, you just plug it in. So here's how I'm going to write plug it in. I'm going to write it in function notation. It is f of the x value. So you would just take the x value, substitute it in for x, and you get the y value. My y-intercept is very simple because remember the y-intercept is substituting in 0. So imagine if I asked you to substitute in 0 in this. You'd have a times 0 squared plus b times 0 plus c. Because these are both containing zeros in them, the y-intercept is actually just the c value. You don't have to do any work when it's in standard form. There it is. There is your y-intercept. All right, let's try this. So here's our first one. Go ahead and take a moment and write down f of x equals x squared plus 4x minus 3. And in fact, please continue to pause the video if you need extra time to write something down. All right, to find the vertex, we have to start with the axis of symmetry. So that means I have to substitute in, the values the opposite of b over 2 times a. So my axis of symmetry is -4 divided by 2, or -2. My vertex value means that I have to now substitute the -2 in and find the y value. So f of -2 means -2 squared plus 4 times -2 minus 3. See, I'm using function notation. Go ahead and simplify that, and that is positive 4 minus 8 minus 3, and you get -7. So that's the vertex, and that's going to go into my chart. -2, -7. And I'm going to choose values on both sides. -1, 0, and maybe a -3, -4. So those are the values that I'm substituting into my table, and I can use those into my function. So I'm going to find f of 0. Oh, wait, that's the y-intercept. So not only am I finding a value for my chart, I'm also finding the y-intercept. So when I substitute in f of 0, I get 0 squared plus 4 times 0 minus 3, and it's negative 3. Well, that means that negative 4 also has a y value of negative 3. Let's substitute in negative 1. F of negative 1 means negative 1 squared plus 4 times negative 1 minus 3. This makes positive 1 minus 4 minus 3, and that should be negative 6. So now I have some values that I can place. Go ahead and pause the video if you want to try it on your own or follow along with me. So I have a U. Do not connect it as a V. It does not come to a point. It is a U. My domain is all real numbers. The range goes from the bottom up, which means I have a minimum value. And my range in this case is from negative 7 to positive infinity. For this one to find the x-intercepts, I want to make the equation equal 0. So just as we've done for all the solving, I have to set it equal to 0, and I can find the x values. So I would have x squared plus 4x minus 3 equal to 0, and I could choose an option from our three options of using factoring, using the quadratic formula, or inverse operations to find the x-intercepts. The x-intercepts are the same as the solutions of solving this. We've got one more example to try. All right, we got another standard form, but this one's a little different. I flipped it over. So again, we're going to start by finding our vertex using the axis of symmetry. The axis of symmetry is x equals the opposite of the b value over 2 times the a value. So my axis of symmetry is going to be a negative 6 over a negative 4, which is positive 3 over 2. You may also write that as x equals 1.5. So there's the first part of my vertex, and I have to substitute in 1.5 in order to find the y value. So I am looking right now for f of 1.5. And you can use a calculator to do this. Just make sure that you're using parentheses when you go ahead and substitute that in there. So when you do the substitutions, you end up with 9.5. So there is my vertex for this graph. So I make my table of values, and I put the 1.5 and the 9.5, and it's not a comfortable vertex, but it is what it happens to be, so I have to work with it. Now because I have this nice axis of symmetry, when I choose a value that's on this side, 1, and I choose a value on the other side, 2, it's going to be symmetric. So I don't have to continue to use decimals. I just happen to have a vertex as a decimal. And then I can choose 0, and I can choose 3. Well, conveniently, 0 is also going to give me my y-intercept. So let's do that one first. F of 0 equals negative 2 times 0 squared plus 6 times 0 plus 5. And just as we suspected, I'm going to get just the constant. It's just a 5. And then down at the bottom, this 3 is also going to give me a 5 if I were to substitute it in. Let's substitute in the 1. It's another nice one. So I have negative 2 times 1 squared plus 6 times 1 plus 5. And that gives me 1 squared is 1 times negative 2 plus 6 plus 5. That should give me positive 9. So those are the values. Go ahead and pause the video if you need an extra second to catch up, or if you want to try graphing it without me. All right, so there is this graph, and it opens down. And that shouldn't surprise us because we know that it got flipped over. My domain is still all real numbers, and my range in this case, because I have a maximum value on my graph, my range goes from negative infinity all the way up to 9.5 included. All right, so this one's falling, which means it's going to cross the x-axis, and I can again set this equal to 0, and I can use whichever method makes the most sense to me, that is the quadratic formula, factoring, or inverse operations to find the x-intercepts. So at this point, you can try it. We can talk about it tomorrow when we get to go through these, or the next time I see you, that is, and we'll get to practice some more and even use our graphing calculators for this as well. So I do have these last problems that I'd like you to try, and I don't want you to actually graph them. I would just like you to find the information for them. So take a moment, pause the video, and write these two problems down. Find the vertex, find the axis of symmetry, the domain range, and the y-intercepts. If you want to challenge yourself, we can definitely find the x-intercepts. Remember, all you have to do for that is to set it equal to 0. And when you set it equal to 0, you can use one of the methods for solving to find the solutions, because if you find the solutions, you've also found the x-intercepts. All right, great job. Thanks for making it through that with me.